Good morning. Welcome back. Overview, I'm going to give you a little bit of history about my lab in particular. DualData, what is it? Heinz Melman is going to give a much better presentation on that this afternoon, so you have to wait for that, but I will give a little bit of background. Why are we using DualData, and then some practical applications that we found within the lab, and conclusions. Who am I? I'm an analytical chemist for 37 years. I've worked on the bench. I've run instruments. I don't run them now. I tell people I'm the pretty face of the company who comes up here and talks to you. And my other partner, which you'll see in a second, he's the one who does a lot of the work. I'm not a toxicologist and I'm not a consultant. But this is my partner. He's just back from the Philippines, where he runs a farm when he doesn't operate a high-resolution mass spectrometer. But he's the one who's in charge of the technical specialties in our lab. You know, we started out 14 years ago, and we started out with the simplest instrument we could get, which was a VG70. Those of you who have been around, those were the workhorses built in the late 80s. They went and went and went until you ran out of parts and you couldn't find anything. But we started with a VG70, moved on to a AutoSpec M-Series Ultima, and for years those were our mainstay. But in 2005, the Dioxin Conference was in Toronto, and being a Canadian lab, we had to have a booth. It was kind of a requirement that if you were Canadian, you had to have a booth. So we did, and right across from us was the Thermo booth. And it turned out Pat knew Nick Binder, who was with IsoMass at the time, and they had a long-standing relationship. And so we got interested in what was going on with the DFS. A couple of years later, Thermo decided to have a workshop much like this, but in Venice. And who doesn't want to go to Venice? Yes, there were some great presentations, but it was Venice. And I learned a little bit more about the DFS and what was available, and I kind of got excited. Pat had been excited for years. Pat's always excited about instruments, any new instrument. I'm glad he's not here today because we'd have to have a GC Orbitrap next week if he was. He just loves the toys. But as our business grew, we ordered our first DFS in 2007. We added another one a couple years later, and our third one in 2015. We also brought in a TSQ Evo over the time period. And then about 4 months ago, we installed DualData onto our DFS. We are a commercial lab. We do a little bit of everything. There's no one focus area for us. Let's be honest, if you're willing to pay us to do the work and you can put it through a GC, it's probably us. But it's got to be a high-res mass spec. We don't do any metals. We don't do any inorganics whatsoever. So DualData, where did the concept come from? For those of you who are dioxin chemists here, the gold standard method is EPA 1613B. And the one thing it says in there is that TCDD cannot elute before 25 minutes. So it doesn't matter how good your mass spec is, how good your columns are, what your resolution is like, you got to wait 25 minutes. And we're in a regulatory environment. If you're in a non-regulatory, you can have it come out in 5 minutes, and that's fine. But when I'm producing data that's going into a regulatory environment, you have to follow the methods. So our runtime for the method, 57 minutes to get it through, because TCDD comes through at a little after 25 minutes, but you still got to get through all the rest of your components. Our actual acquisition time is 33 minutes. So from where we want to start looking at things to where we finish looking at things is just 33 minutes. So we've got about 24 minutes of wasted time in there. And in a commercial lab, that's just deadly. So what do? We brought in DualData. And with DualData, what they do, aside from some gas lines in here, they, let's see if I can hit a right button. Oh, good. They put in a little wafer where you take your column out of the injector, you plug it into the wafer, and then there's another column that goes from the wafer into the DFS. And this valve in here allows you to either vent the GC column into the DFS or vent it to atmosphere. Now, here you see a staggered projection of running. And what we really want to do is start injecting. We have dual GCs on all our high-res mass specs. So not just singles, one on either side, much like you saw in Tom's lab during the walkthrough a little while ago. So what you want to do is you want to inject on the second GC about 20 minutes before the first GC is finished. And you can stagger your injections and then go back and forth between the two instruments. Now, why do you want DualData? Well, the simple thing is it's cheaper than buying a new instrument. Instruments are expensive. They do a great job, but if you can get more out of your instrument, let's face it, that's what we all want. You need no additional floor space. You're not adding another instrument. You're just building into what instrument you have. No electrical considerations. I've got a 30 amp service into my office. I can only get so much electricity without having the BC Hydro come in and redo our electrical service, which would be a small fortune. One of the neatest things with this is that the auto sampler is ready to inject as soon as it gets the ready signal. If some of you have older DFSs or the standard DFS, once the ready signal goes, that's when the auto sampler starts going through its dance routine and takes about 3 minutes to wash the syringe, to load the syringe, and do all the rest. But with the new software, all this is being done before it gets the ready signal, rather than at the point it gets the ready signal. And I'm going to show you in a little while how we can double our throughput with mixed chemistries. Not just by running dioxins, but by running a whole range of different compounds. Now your requirements, you do have to have 2 GCs, and they do have to be 1310s. Our first 2 DFSs were with trace GCs, slightly bigger GC. They won't work with DualData. They can be converted, but you can't use them. You need this little valve in here. I keep calling it a 6-way valve, but I'm not sure it is a 6-way valve. It's a 4-way valve, isn't it? Oh, well, I'll get that right one of these days. And I know Thermo has an acronym for it, but I can never remember it, so I just call it a 6-way valve, and you'll have to forgive me for that. We get a little gas module installed on the top of the GC. That's your injection port. This is the gas module. And it covers up nicely so that you're ready to go. And of course, you get new software to play with. On the software, when you're setting up, it looks just like the regular software if you've got a DFS. There's nothing too extraordinary in here. You just have 2 MIDs that you can put into here. So when you start your system up, you're going to run dioxins. The first thing you want to do is put in your wait time. So we've got 20 minutes of time in here, and that tells it that it can start the other injection to collect 20 minutes before this one is ready to finish. We put that number, our end time, on the first run, and then we start going through. You select DualData mode up at the top here, and then you start building your function. Tetras, pentas, hexas, heptas, octas, just the way you normally would on a DFS. You go in and you have a choice. With DualData, you can still run in a single mode. And running in a single mode is still quicker than running the old style in a single mode. But you can run single or DualData in here. So DualData dioxins. We have our run here is 62 minutes or 23 injections per day. That's running in a single mode. But when you overlap it and go through here, it only takes 67 minutes, so an extra 5 minutes to complete 2 cycles. So that's 2 runs in 67 minutes rather than 1 run in 62 minutes. So you get 42 injections in a 24-hour period rather than the 23. Now, resolution, you've got that wafer in there, you've got a connection column, a few silica column, but we still have perfect resolution for TCDD. That's the easy one. We use a ResTech Dioxin 2 column. You shouldn't have any problem with resolution on it, and indeed we don't. There's good resolution from all the other nearest TCDFs. Hexa, again, no problem. Baseline there, essentially baseline resolution. So adding that wafer in there doesn't change anything as far as your resolution goes. TCDD, this is a CS low, 0.1 picogram, 100 femtograms injected. Again, no problem. This is a DFS. This is easy for DFS to get down to there. This is a 20 femtogram injection right here. A little noisy on the first channel, but you can clearly see it on the second channel. No problem with 20 femtograms injected. Now, as I said, we don't just run dioxins. We do a lot of PCBs. Our PCBs, more often than not, are 209 congener PCBs rather than the Who's and markers. Who's and markers are always simpler. But it's 68 minutes for running PCBs by themselves. But if you run with DualData, in this case here, we're for dioxin-like PCBs, 74 minutes to complete a cycle, and that's to complete a cycle of 2 runs. So you get 82% more samples in there. Now, if you're, that one actually was for dioxin-like PCBs. We have a quicker end cutoff on that. But if you do 209 congener PCBs, 30 injections per day is pretty good. And you have to remember that with PCBs, if you're running by 1668, PCB 209 can't elute until 55 minutes. So there are some retention time issues with that as well. Hexas, this is the dioxin-like are at 0.1 picogram, and the markers are at 0.5 picograms, but no problems with resolution again or sensitivity on this column. We set up BDEs on here, as was previously noted in a talk. BDEs, especially BDE 209, can be a lot of fun if you're not careful. So we were concerned that maybe there might be some issues with the wafer in BDE 209. In simple terms, yes, you can run dual BDEs. Quite frankly, we never have enough samples of BDE in-house to want to go that way, but it is possible, and you don't have a lot of front time on here. I think we've just got a 4-minute delay at the front, so you're not saving a lot, but you can save time by running them dual data. Tetras, this is a 0.5 picogram injection. All the Tetras are there. We've got our resolution requirement on 4971, so no problem there. But what happens with the DECA, this is 2.5 picograms of DECA injected. Not a problem there. You can take it and keep running your standards up from 2.5 up to I think it's 2.5 nanograms for the top standard. There's perfect linearity. I didn't bother to put up linearity charts in here, but they're all meet all the requirements of the methods, which means no more than a 20% variation on the RSDs for the RRFs. We do a lot of OCPs in-house. With the OCPs, we've got about a 10-minute wait at the front of the OCPs. So there is an advantage to using DualData in there. We go from 51 minutes up to 64 minutes, but 64 minutes for 2. So again, 57% more samples going through there. So running dual chemistries does work, but our workload, as you can see here, is all over the place. Dioxins and PCBs about equal with some OCPs in there, a little bit of PBDs. We don't run too much of we used to run PAH exclusively off the high res. We still run a fair amount, but not exclusively. So we want to look and seeing how can you combine different chemistries on this instrument. Well, if you look again at the dioxin run, which I said was 62 minutes to run a dioxin, with that 20-minute wait time at the beginning. You then go to the PCBs. For who's and markers, it's a 48-minute run time. But when you put the two together, it's 57 minutes. So you can actually run the dioxin and the PCB in less time than it took you just to run the dioxin by itself. So you've got a free injection in there. It's amazing. Now, if you go to 209 congener PCB, it's a little bit more because we can cut off, because we have to stop with the who's and markers, we can stop at PCB 189. So you don't have to, you can burn off to vent for the rest of the PCBs up to PCB 209. But in reality, you get 2 injections for the price of 1 on the same piece of equipment. Here's the data for 209. It takes a little longer to run both of them, but still a great savings of times. And more often than not, especially in the commercial lab, if you've got a dioxin sample, you've got a PCB on exactly the same sample. So you can run the 2 of them together at the same time. We do a lot of tributyl tin analysis. We used to run it mainly we used to only have high-res mass specs, so we'd put it on there. Now we tend to put it more on the TSQ. But again, the 56 minutes in there, you get a free injection. And what we found with more and more of our chemistries, we'll run dioxins on one side and get the free injection with something else on the other side. OCPs, dioxins and OCPs, not quite a free injection, but pretty darn close, going from 62 minutes to 66 minutes for 2 injections. Again, almost doubling your throughput on the machine. Lastly, you could try dioxins and PBDs on there in theory. Just adding 2 more minutes onto your runtime. The biggest problem is that PBDs typically are not run at 10,000 resolution. 1614 calls for a 5000 resolution on them. So if you want to run with the higher resolution, you can do it. You might lose a little sensitivity, but in theory you can do it. As well, in our lab, we use a different tuning compound for PBDEs versus dioxins or other things. So, you know, you have to run the same tuning compound. It just goes without saying. So we could switch our dioxin method to run the same tuning compound as we ran with our PBDE method. But I show this more just to show what's possible rather than what you really would do on there. Conclusions, I mean, real obvious. It saves time, even when running in a single GC mode. You're not limited. You've got 2 GCs, put 2 different columns in the 2 GCs and run mixed chemistries. As I've just showed you, more often than not, the mixed chemistries are quicker than running each of the individuals. Sources. One little advantage, because you're not burning off everything into the source at the end of your run, you're venting it, you don't have to change your sources often. You know, that's a real saving right there. The wafers, this little guy right in here, they should be considered a consumable, but they can also be cleaned. We've developed some cleaning techniques for them and have had no problems with cleaning them. They do need to be cleaned initially and after so many injections. But you know, you can replace them, you can clean them. We haven't had the system long enough to really come up with a set pattern of how long we have to do either one of them, but it is possible. Lastly, the source doesn't need to be vented when you change columns. Because you've got a few silica column going from the wafer into the source, you aren't venting it. You can change a column on the front end in 5 minutes, and you don't have to take it down and bring the vacuum back up again. So you can save yourself a lot of time there. The on here, you can't quite see it, but there's some little nuts on there which are just hand tightened. You don't use wrenches, you can just hand tighten them, and they work. That's the thing that surprised me the most, is they actually work. I've seen so many connections that promise you the world and they fail. You know, you get air leaks, everything problems. These work. That's the end. I want to remind everybody to be coming to Vancouver in August. The Dioxin Conference will be taking place in Vancouver, in my hometown, the 20th to the 25th. Moran wanted me to tell you that he's got some giveaways at the back, some bags, some other promo material. He's already packed his suitcase. He doesn't want to take it home with him, so please grab one for him. And hopefully you can come to Vancouver, and if you want to go sailing, you can go sailing. I don't think we'll have quite as hot a weather as what we had yesterday here, but hopefully should be in the mid 25s, so 80 degrees, something like that. But welcome, and thank you very much.
Thanks, David. Any questions for David?
I just have one quick question for David. You were mentioning the column you use for the dioxins. Are you using the same column for the congeners, or are you using the specialty column?
We use SGHT8 for PCBs and the ResTech dioxin. We use a different column for every chemistry we do. I don't think there's two the same.
All right, thank you.
When you're running your calibration, you consider the two GC two separate?
Yes.
So if you do QC, everything?
You got it. When you do your calvaires, you have to run a calvaire on each side. One of the nice things is when we run dioxins and PCBs, you run a calvaire dioxin, you run a calvaire PCB. Normally after running a calvaire, we'd run a blank just to do it. But because your syringe has just injected a PCB, that's no longer an interference. So you no longer have to put that blank wash in there because you've essentially washed it with the other standard or sample.
Any more questions? On this side of the room anyway? Okay. All right, thank you very much, David.
Thanks.